So location of resistances. Uh, so it talks. There's some literature about how the location varies by different kinds of soils. So the ground rods are usually are very highly conductive in nature, and they're usually made of steel or copper, commonly used material for the ground rods. And the contact resistance of the ground rod and the earth is negligible as well. Then the resistance of the surrounding body of Earth. We'll look at the spheres of influence in a while, but that plays an important role as well. Let's look at what affects the grounding resistance. So there are a few factors that affect the grounding resistance. For example, the length and the depth of the electrode that affects how much resistance you're going to measure, the diameter of the electrode, the overall system design, temperature, and the number of electrodes. And this NEC article 250.52 calls out for an 8 feet minimum length for the ground rod. So usually that's the standard out there in the industry as well, 8 feet ground electrodes. So let's look how each one of the factors affect the grounding resistance. So first one was the length and depth of the ground electrode. So an effective way of lowering the ground resistance is to install these ground electrodes as deep as possible into the earth. So it says by doubling the length, we are basically achieving 40% lower grounding resistance. So that has a very, very big impact on the resistance values. Diameter doesn't play that much of a role. Increasing the diameter only reduces the resistance by 10%. Temperature plays an important role as well. For example, between 25 degrees C and 0 degrees C, the temperature, the resistance kind of slows down gradually, but once it's below freezing point, below 0 degrees C, the resistivity increases rapidly. So that's why in frozen soil, the surface layer, has a very high resistivity. Next, we'll look at the ground rod sphere of influence. So what is it and how it's important as well. So we just talked about the resistance of the electrode, how different factors affect it, how the contact resistance between the electrode and the soil plays an important role as well. And now we'll look at what do we call as sphere of influence. Jatinder says in Canada we generally drive 5-meter deep ground rods. Okay, due to frozen soil in winter. Okay, is that the standard, Jatinder, in Canada? Does the standard call out for 5-meter? Okay, it's the practice by local utilities. Okay. So what's a sphere of influence? So when you insert this ground rod, into the earth, there is this outside, area or the surface area surrounding the ground rod that plays an important role in the gradual reduction of resistivity. Anything beyond the surface has zero resistance, but this area surrounding the ground rod is playing an important role in reducing that resistivity. That's why there is a chance of a ground potential rise in this section of the area when there is a fault. So when the fault current dissipates into this ground rod, there is a chance of GPR rise. So that's why in substation yards you would often find the crushed rocks on top of the surface in order to mitigate that GPR rise, because you have your surface on top of the ground rods.